This section is about hypothesis tests. A hypothesis test is an important process in inferential statistics. A hypothesis test will use a sample statistic to test a claim about the value of a population parameter. For example, let's say a manufacturer advertises its new hybrid car as having a mean gas mileage of 50 miles per gallon. What would it take to show that the advertisement was false? Well, we certainly cannot test all the vehicles. There's too many of them. But you could test the gas mileage of a sample of the population. So assume you do collect a sample of n equals 30 of these vehicles. You find your sample mean to be x bar equals 47 miles per gallon lower than the manufacturer had claimed. Does this prove that the manufacturer was lying? Does the sample mean differ enough from the advertiser's claim of mu equals 50 miles per gallon to indicate that the advertisement is in fact false? First, let's give the advertiser the benefit of the doubt and assume that their claim actually was true. Assuming that the population mean was actually what they had said, 50, and our sample mean was 47, let's just calculate the sample error. Sample error has a formula: x bar minus mu. It gives us a -3. That shows that we were 3 miles per gallon below the true population mean. Now we already know from our past that it's virtually certain the sample mean will be different from the population mean, simply due to random variations in each individual member of the population. However, we also know that the more population members we sample, the more likely it is that our sample mean will be near the population mean. That's the law of large numbers. Is it possible that the ad's claim actually was correct, and we just got a lower than average sample by chance? Mathematically, we have to concede the possibility that that is the case. It is possible. Is the sample mean different enough, though, to warrant rejection of the manufacturer's claim? Possibly. And that is the subject of this section. So, the above type of question is one that hypothesis testing can answer. But we have to keep the following principles in mind. There's never any absolute certainty when it comes to this type of investigation. A fundamental principle of inductive reasoning in inferential statistics is that if we cannot test every population member, we'll never really know with 100% certainty whether or not claims made are true or not. We can, however, have reasonable certainty, and we'll acknowledge the above issue by having a level of confidence or a level of significance whenever we make a hypothesis test decision. The statistician has to decide how much of a difference between the claim and the sample is too much to accept. Sometimes we'll reject a claim. We'll show that a claim is so unlikely to be true that it would be unreasonable for us to accept. And so when evidence to the contrary becomes so overwhelming, we'll have to say that there's enough evidence to reject the claim. And at other times, evidence will support a claim. However, we'll generally never say that a claim is definitely true. We'll just say the evidence supports the claim. These are all issues that we'll explore in the next few videos.